So today I'm going to be talking about the chain rule. So the chain rule involves finding derivatives of compositions of functions. So basically function composition is when you take one function and you plug it inside of another function. So for example, suppose I have these two functions, f of x and g of x, and I want to find the composite function, which is written as f of g of x. Well, what I would do is I'd take this formula for g of x and I'd plug it in for everywhere I see an x in f of x. So in this case, I would get 1 divided by x squared plus 3 times 1 divided by x plus 2. And this would be my composite function. On the other hand, if I do it the other way, then I would be plugging in the formula for f of x everywhere I see an x in the g of x formula. So in this case, the equation would look something like 1 over square root x squared plus 3x plus 2. So then the chain rule tells us how to take derivatives of functions that look like this. So what does this rule tell us? It says that if f and g are differentiable functions, then the derivative of the composite function f of g of x is equal to f prime of g of x times g prime of x. So this is the chain rule. I'm not going to prove this. We can just take it for granted. So let's see though how we can use this rule to calculate derivatives that we couldn't do before. So as a first example, let's look at the function f of x equals, let's say, x cubed plus 3x plus 9, all raised to the 14th power. So strictly speaking, we could have done this derivative before using just the power rule by multiplying all of these terms out. You'd get some really long polynomial with x's in it, and then you could use the power rule. But it would be very tedious because expanding something to the 14th power is going to take a very long time. So we can do better if we use the chain rule. For convenience, let me actually give this function a different name, h of x. And so if we look at our formula for the chain rule, we want to try to interpret h of x as a composite of two functions, f of g of x. So in this case, if we think of this entire thing inside here as g of x, then we see that with the choice f of x equals x to the 14th and g of x equals that polynomial, then h of x is equal to f of g of x. So basically we've identified an inside function, the g of x, and an outside function, the f of x, and rewritten the function we want to take the derivative of as a composite function. So now we can easily calculate by the power rule that f prime of x is 14x to the 13th, g prime of x is equal to 3x squared plus 3. And so by the chain rule, h prime of x is going to be equal to f prime of g of x times g prime of x. This is going to be equal to 14x to the power 13, but we're not plugging in x, we're plugging in g of x. So g of x was x cubed plus 3x plus 9. And all that gets raised to the 13th power. So this term is the f prime of g of x. And we have to multiply by g prime of x, which is 3x squared plus 3. And so that is our final answer for the derivative. Okay, let's take a look at another example. let's suppose we want to find the derivative of the square root of x cubed plus 3x plus 2. So in this case, this is not something we could have calculated before by just expanding, because we have a square root, and so we have to use the chain rule. And we identify the outside function as f of x equals square root x, and then the function on the inside is this x cubed plus 3x plus 2. So then we can calculate f prime of x is equal to 1/2 x to the negative 1/2. G prime of x is 3x squared plus 3. And so that means that this derivative we want to calculate by the chain rule is going to be equal to 1/2 times x to the negative 1/2, but we're plugging in g of x by the chain rule. So this becomes x cubed plus 3x plus 2 to the negative 1/2 times g prime of x, which is 3x squared plus 2. So this term was the f prime of g of x, and this term was the g prime of x in this example. Okay, let's do one more example. So let's suppose that we have the function h of x equals square root x plus 1 over x minus 1. So in this case, the inside function is going to be the x plus 1 over x minus 1. The outside function is the square root. So we have f of x equals square root x, g of x equals x plus 1 over x minus 1. Now in order to use the chain rule, we need to know f prime and g prime. So f prime we can calculate it. In fact, we already did it in the last example. So it's 1/2 x to the negative 1/2. But for g prime, we see we have division of two different functions, so we have to use the quotient rule. So the quotient rule says we take the derivative of the top, which is 1, multiplied by the bottom, so x minus 1, minus derivative of the bottom, which is again 1 times the top function, x plus 1, all divided by the bottom function squared. Now normally I say that when we use the quotient rule we don't bother simplifying our answers, but in this case I think it's worth doing because it simplifies quite nicely. And it's fairly easy to see. We have an x minus x, so those cancel. Then we have a negative 1 minus 1, which just gives us negative 2 over x minus 1 squared. So now that we've calculated g prime, even though we had to do a sub-problem involving the quotient rule in order to get there, once we have the formula for g prime, we're still back into the situation just plugging into our formula for the chain rule. So h prime of x is f prime of g of x, g prime of x. And so this is equal to 1/2 g of x to the negative 1/2, which is this, times the formula we got for g prime of x. And in this case, that can be simplified. There's a 2 which cancels with the 1/2, and so we get negative 1 over x minus 1 squared times x plus 1 over x minus 1 to the negative 1/2 power. And that would be our final answer for the derivative. So when using the chain rule, basically there's 3 steps, I guess. You identify the inside and the outside function so that you make the function you're trying to take the derivative of look like a composition of two functions, f and g. Then you find the derivatives of those two functions, and then once you have your derivatives, you can just go back up to your formula for the chain rule and plug things into that.